We will now demonstrate how SQL injection can be leveraged to bypass user authentication. Here, we have a typical logging screen. Legitimate users, like John Smith, can enter their username and password to get access to the system. So let's enter Smith J and his password secret1. So now I'm logged in as John Smith, as you can see here. Let's take a look at what happened in the background. After receiving the user's input, the web application dynamically created the following SQL statement before sending it to the backend database. So here we have select star means all columns from the table users, where the column name username is equal to SmithJ, and the password column is equal to secret1. So as you can see, the application wants to get all records from the users table where the following condition is true. And since there is a user matching these criteria, one record is returned to the web application, which proceeds to grant John access to the system. Now let's log out and see how hackers can get access to this system using SQL injection. One of the first things an attacker would do is determine if there is indeed an SQL injection vulnerability present in a website. One way of doing this is to insert reserved SQL characters into each form fields to see if it causes an error. So here's an example of reserved SQL characters. The first one that we've seen before, a star, means select all columns, while these two are character string delimiters. So basically they tell the backend database where a string starts and where it ends, while the other two, these two, tells the backend database that everything following these characters should be considered as a comment. Okay, so and therefore should be ignored by the backend database. The process of trying many different character sequences to see how the application behaves is called fuzzing. So let's try to manually fuzz our logging screen. I will start with the star, and I won't enter anything in the password field. I'm just testing the user input field for now. So I'll click on submit, and obviously since there are no credentials matching the values that I've entered, which is just a star in the backend database, then the application told me that the login attempt failed. So let's try again now with double quotes. Again, login fail. Single quote. Look at this. We have received an error from the application. Errors like this one, displayed directly to the user, are unfortunately quite common in web applications. This particular one tells us three important things. One, there is indeed an SQL injection vulnerability in this website. Two, it's exploitable using a single quote. And three, the backend database is MySQL. Now let's go back to the SQL code in order to understand what just happened. The username value that I've entered is a single quote, while the password field was blank. So that's what was sent to the backend database. But like we saw here, single quotes are character string delimiters. So they tell the backend database where a string starts and where it ends. So here we have 3 single quotes in a row. So the backend database got confused with that, right? So it thinks that this one start a character string, which is an empty string in our case, and this one, sorry about that, this one ends this string, okay? So basically the username value should be between these 2 single quotes. So the backend database doesn't know what to do with a third single quote, hence the error that we received. So the database got confused between values and code, hence the SQL injection vulnerability. But hackers want valid SQL statements to reach the database. So one way to achieve this is to comment out everything following our single quote. We can do this by entering the £, like we've seen here, okay? Now we know that we're dealing with MySQL, so we're using this one, okay? So that's our value for our username field. And since everything following the £, would be ignored by the backend database, it's basically like if we are sending this to the database only. Okay? So let's give it a try. I will copy this. And try this out. Notice that the application did not send us an error message because the resulting SQL statement is now valid. So at this point, if I go back to SQL code, if the attacker knows a valid username, he's able to log in without knowing the password. Can you see how? It can be done by entering something like this. Okay, so this part here is what we'll enter in the user form field. Okay, so why does it work? Again, this part here will be ignored by the backend database. So this query select all columns from the users table where the username equals SmithJ. Since SmithJ is a valid username, this will return true. Therefore, the whole statement will return a valid record. Okay? Let's give it a try. As you can see, we are now logged in as John Smith without having to enter his password. So this is an example of broken authentication leveraged through an SQL injection vulnerability. But let's assume the attacker doesn't know any valid username. There's still a way to log in. As discussed earlier, we need the where clause to return true in order to log in. We can achieve this by using the OR logical operator. Let's see how. So again, I don't know any valid usernames. So what I can do here is add OR 1 equals 1. So effectively, we have a where clause where this or this must be true. Since 1 equals 1 is always true, this whole where clause here will always return true. Let's give it a try. As you can see, a hacker can completely bypass the authentication mechanism and get access to the website simply by injecting SQL code in the username form field. Notice that this attack would still be possible even if the passwords were properly hashed in the database, and if the application was implementing SSL to protect data in transit. But can we do more? There are many tools available to exploit SQL injection vulnerabilities, but a very popular one is SQL Map. This tool can enumerate backend databases and download all their data. Let's see how it works. But first, we need to know what's the URL used to submit the user's credentials to the server. We can quickly find it by simply looking at the source code of the login page. Here, we can see that the login requests are sent to the Big Bang check credentials URL, and it uses the username here and the password input parameters. Let's feed this information into SQL Map. So I'm using SQL Map to target this URL, okay, which is a Big Bang server, and we're sending the request to the check credentials URL. As data, we have to tell SQL Map which field to fuzz, and in this case, it's the username form field, sorry. And what we want to do is we want to do a database search. Let's see what it can do. So quickly, we're able to see here 4 different databases. Let's select the Big Bang database here, okay? And now we want to enumerate all its tables. As you can see, we found 6 tables, but the credit card one looks quite interesting. So let's select this table and let's dump all its data. Look at this. We have successfully downloaded all credit card numbers from this database. I hope this presentation was enough to convince you that SQL injection vulnerabilities have to be taken very seriously. Thank you.